These 40,000 sardines will become 8,000 sealed cans before the morning shift ends. Each fish must be positioned into its can by hand in exactly 3.5 seconds, or the entire production line backs up. Today, we are following every step of this transformation to reveal the precise choreography behind one of the world's oldest preserved foods. The journey begins long before the factory doors open. Out on the dark Atlantic waters, fishing vessels work through the night. These boats carry technology that would seem like science fiction to fishermen of previous generations. Sonar systems can detect sardine schools swimming up to 300 meters below the surface, tracking their movement in real time. When the captain locates a promising school, the crew has only minutes to deploy their nets before the fish scatter. What happens next determines whether this factory will have raw material to process or stand idle for the day. The purse-seine net forms a massive underwater wall nearly half a kilometer long, encircling the sardine school from below. Hydraulic winches pull cables that close the bottom of the net like a drawstring bag, trapping everything inside. The trapped fish begin to surface as the net tightens, creating a boiling mass of silver that can weigh over 50 tons. A suction pump drops into this living mass, pulling sardines up through a wide hose at a rate of 20 tons per hour. The fish travel through the pump and directly into refrigerated holding tanks built into the vessel's hull. Chilled seawater keeps the catch at exactly 2 degrees Celsius, preventing bacterial growth during the journey back to port. Speed is critical. From the moment sardines leave the water, the factory has less than 24 hours before quality begins to decline. The fishing boats radio ahead to the factory, reporting their catch size so processing teams can prepare for arrival. At the dock, workers have already begun setting up the unloading equipment that will transfer the catch to the factory. The vessel backs into position against the unloading pier, crew members throwing heavy mooring lines to dock workers below. Large diameter hoses connect the boat's holding tanks to pumps on the dock, creating a direct pipeline from sea to factory. The suction begins and sardines flow upward through the transparent sections of hose, a river of silver ascending from the hold. Each boat typically delivers between 30 and 50 tons of sardines, enough raw material to fill 60,000 cans. The sardines tumble onto a conveyor belt that carries them directly into the processing facility, their factory journey beginning. Quality inspectors stationed at the entry point examine random samples, checking size uniformity and freshness indicators. The eyes should be clear and bright, the flesh firm to the touch, and the distinctive sardines smell clean rather than overpowering. Any batch failing these standards gets rejected immediately. There is no room for compromise when food safety is at stake. The approved catch moves deeper into the facility, entering a processing area kept at a constant 4 degrees Celsius. The first major processing step is sorting. Sardines vary in size and different can formats require specific fish dimensions. Mechanical graders use precisely spaced bars that allow smaller fish to fall through while larger ones continue forward. This automated system can sort over 10 tons of sardines per hour, separating them into 5 distinct size categories. The smallest sardines typically go to budget product lines, while larger fish command premium prices in export markets. After sorting, the sardines enter a massive washing system that removes scales, slime, and any debris from the ocean. High-pressure water jets blast the fish from every angle as they tumble through rotating drum washers. The wash water is constantly filtered and recycled, with the factory processing over 200,000 liters daily. Clean sardines emerge glistening and ready for the next critical step, one that requires both speed and precision. The heading and gutting line stretches nearly 30 meters across the factory floor, staffed by workers whose hands never stop moving. Each worker performs a single specialized task, creating an assembly line efficiency that maximizes throughput. The first station removes heads with a single precise cut, angling the blade to preserve maximum flesh while eliminating the skull. Experienced workers can head over 40 sardines per minute, their muscle memory making each motion automatic. The gutting station follows immediately, workers making a single incision to remove internal organs in one smooth pull. This step must be performed carefully. Any rupture of the gallbladder would taint the flesh with bitter compounds. A final inspection station catches any fish with remaining viscera, damaged flesh, or other defects that slipped through. The waste from heading and gutting does not go to landfill. It travels to a separate facility to become fish meal and fish oil. Nothing is wasted in modern sardine processing. Even the washwater nutrients get captured and repurposed. The cleaned and gutted sardines now enter a brine bath, a salt solution that firms the flesh and enhances flavor. The brine concentration is precisely controlled at 18% salinity, monitored continuously by electronic sensors. After exactly 12 minutes in the brine, the sardines emerge ready for the step that defines this entire industry. Everything until now has been preparation. What happens next is why sardine canning remains one of the most labor-intensive food industries on Earth. Despite decades of automation attempts, no machine has ever matched human hands for the delicate task of arranging sardines in cans. Each packer sits before a stainless steel station with a supply of empty cans on one side and prepared sardines on the other. The empty cans arrive already sterilized, traveling on conveyors from a separate preparation area of the factory. Standard cans hold between 3 and 5 sardines depending on fish size. The packer must judge instantly how many will fit. The first fish goes in head end first, pressed against the curved wall of the can with the tail curving upward. The second fish mirrors the first, head at the opposite end, creating the classic alternating pattern consumers expect. Speed and aesthetics must balance perfectly. Consumers judge quality partly by how orderly the fish appear when they open the can. A skilled packer completes one can every 3.5 seconds. That is over 1,000 cans per hour from a single worker. Watch closely, and you will notice packers barely look at their hands. The movements have become entirely automatic. New workers spend weeks training before reaching full speed, their fingers learning the exact pressure needed for each placement. The physical demands are significant. Repetitive motion injuries are a constant concern, requiring regular rotation between tasks. Filled cans move immediately to weighing stations where electronic scales verify each one meets the declared content weight. Underweight cans get flagged and returned for additional fish. The label promise must match the actual contents exactly. Approved cans continue to the filling station where liquid is added. This is where sardines transform from fresh fish to shelf-stable product. Different products receive different liquids. Traditional olive oil, lighter vegetable oil, tomato sauce, or mustard sauce depending on the product line. The olive oil version commands premium prices using oil imported specifically for sardine packing from Mediterranean suppliers. Filling happens with millimeter precision. Too much liquid causes overflow during sealing. Too little leaves air pockets that accelerate spoilage. Tomato sauce versions require heated filling to maintain proper viscosity as the sauce flows over the fish. Spiced versions add whole peppercorns, bay leaves, or chili slices before the liquid, each ingredient positioned by hand. The filled cans now approach the sealing machines, the critical equipment that determines whether these products survive years on store shelves. Modern double-seam sealing technology creates an airtight bond between can body and lid that no bacteria can penetrate. The process happens in 2 stages. First operation curls the lid edge under the can body flange. Second operation compresses them together. Each sealing machine processes over 100 cans per minute, the rhythmic mechanical sound becoming the factory's heartbeat. Sealed cans immediately enter a washing tunnel that removes any oil or sauce residue from the exterior surfaces. Hot water jets blast the cans from every angle, while rotating brushes scrub away any contamination. Clean cans emerge dripping but spotless, ready for the heat treatment that gives canned sardines their remarkable shelf life. The retort sterilization system towers 3 stories above the factory floor, capable of processing 20,000 cans per batch. Workers load sealed cans into metal baskets that stack inside these massive pressure vessels, like layers in an industrial wedding cake. Each basket holds approximately 2,000 cans, and a full retort cycle processes 10 baskets simultaneously. The heavy steel door swings closed with a deep metallic clang that echoes across the factory floor. Inside, the temperature climbs to 121 degrees Celsius under pressure equivalent to 2 atmospheres. This combination of heat and pressure destroys all bacteria, spores, and enzymes that could cause spoilage or food poisoning. The sardines cook in their own juices during this process, the heat transforming raw fish into the tender, flaky texture consumers expect. Processing time varies by can size. Standard cans require 65 minutes at full temperature to achieve complete sterility. Rushing this step by even 5 minutes could leave viable bacteria that multiply during storage, a risk no reputable factory takes. When the cycle completes, cold water floods the retort chamber, rapidly reducing temperature to stop the cooking process. The pressure equalizes slowly to prevent sudden changes that could deform the thin metal can walls. After 30 minutes of cooling, the heavy door opens to reveal thousands of perfectly sterilized cans, still warm to the touch. These cans now have a shelf life measured in years. Properly stored, they remain safe to eat for up to 5 years. But the journey through this factory is far from over. Every single can must prove it deserves to reach store shelves. The cans enter a drying tunnel where hot air removes all moisture that could cause rust during storage. Even a single drop of water trapped under a label could create a rust spot that consumers interpret as damaged goods. Dried cans pass through electronic inspection systems that detect any deformation in the sealing seam. Laser measurements verify the double seam dimensions match specifications to within 1/100th of a millimeter. Any can with a seam outside tolerance gets rejected instantly. There is no second chance, no manual override possible. Random samples from each batch get pulled for destructive testing, the cans literally cut open to verify internal quality. Technicians examine fish arrangement, measure oil coverage, and test for any off odors that indicate processing problems. These samples get documented photographically, creating a permanent record that traces back to specific boats, catches, and processing times. If any batch fails testing, every single can from that production run gets quarantined until the problem is identified. Approved cans move to the labeling lines where plain silver containers become recognizable consumer products. This factory produces cans for over 40 different brands, each requiring its own label design and specifications. The labeling machine applies a thin layer of food-safe adhesive, wraps the paper around the can, and seals the overlap in one continuous motion. Label alignment must be perfect. Crooked labels suggest poor quality even when the contents are identical to premium competitors. Inkjet printers then add production codes directly to the can surface, marking batch numbers and expiration dates. These codes allow complete traceability. Any consumer complaint can be traced back to the exact hour the can was produced. The coding system links to fishing vessel logs, revealing which boat caught the fish in any specific can. Labeled cans pass through a final visual inspection where workers check for any printing errors or damage. Any label bubble, tear, or smudge means rejection. Consumers pay attention to packaging details more than manufacturers often realize. Approved cans accumulate on collection conveyors, building into streams of product ready for packaging into retail units. Automated case packers arrange cans into cardboard boxes with mechanical precision, each box holding exactly 24 cans. The boxes get sealed with tape, labeled with contents and destination information, and stacked onto wooden pallets. Each pallet holds 60 cases containing 1,440 individual cans, stacked 5 layers high for shipping efficiency. Stretch wrap machines cocoon each pallet in protective plastic film, securing the cases for transportation across oceans. The wrapped pallets receive a final barcode label linking them to the complete production documentation stored digitally. Forklifts transport finished pallets to the warehouse, a climate-controlled space holding millions of cans awaiting shipment. The warehouse maintains constant temperature and humidity to prevent any condensation that could damage labels during storage. Some products ship within days of production. Others wait months for orders from distant markets around the world. Export orders require additional documentation, with health certificates and customs paperwork prepared for each destination country. Different countries have different labeling requirements, sometimes necessitating additional stickers with translated information. Container trucks arrive at the loading dock throughout the day, each one capable of carrying over 20 tons of canned sardines. Forklifts shuttle pallets into the trailer, drivers securing each load to prevent shifting during the long journeys ahead. Temperature monitoring devices get placed inside containers bound for hot climate destinations to verify cold chain maintenance. The container doors swing closed on cargo that began this morning as living fish swimming in the Atlantic Ocean. Within weeks, these cans will appear on store shelves from Lisbon to Lagos, from Tokyo to Toronto. Throughout this entire process, quality control operates as a parallel system, constantly monitoring every production variable. Incoming fish quality gets tested for mercury and other heavy metals that accumulate in marine food chains. These tests use atomic absorption spectroscopy, detecting contaminants at concentrations of parts per billion. Any fish batch exceeding safety thresholds gets rejected entirely, regardless of the financial loss to suppliers. Microbiological testing happens continuously, with technicians culturing samples to check for harmful bacteria presence. Incubators hold hundreds of test samples at precise temperatures, allowing any surviving organisms to multiply into detectable colonies. After 48 hours, technicians examine the cultures. Clean plates means sterile product. Any growth triggers investigation. Oil quality testing verifies that filling liquids meet purity standards and have not degraded during storage. Can integrity testing subjects random samples to pressure extremes, verifying seals will hold under any normal storage condition. Some cans get deliberately incubated at elevated temperatures, an accelerated aging test that simulates years of shelf storage in weeks. After the aging simulation, cans get opened and evaluated for any changes in appearance, texture, or flavor. Trained sensory panels conduct blind taste tests, comparing production samples against established quality benchmarks. These panelists can detect flavor defects that instruments cannot measure, the human palate remaining irreplaceable for certain evaluations. All test results feed into databases that track quality trends over time, identifying potential problems before they affect consumers. This relentless testing regime is why major food recalls in canned seafood remain extraordinarily rare despite massive production volumes. Back on the packing floor, the morning shift nears its end. The production board shows today's output approaching 45,000 cans. That number represents over 8 tons of finished product created from fish that were swimming in the ocean less than 20 hours ago. The transformation we have witnessed today happens here 5 days every week, producing over 10 million cans annually from this single facility. Similar factories operate along coastlines worldwide, from Portugal to Peru, from Morocco to Maine. The global canned sardine industry produces over 2 million metric tons annually, feeding hundreds of millions of people. For many communities, sardines represent affordable protein security, a nutritious food source that requires no refrigeration. The omega-3 fatty acids in sardines provide health benefits that nutritionists increasingly recognize as essential. And because sardines sit low on the marine food chain, they accumulate fewer toxins than larger predatory fish species. The workers who make this industry function bring skills passed through generations of fishing communities. Their hands convert the ocean's abundance into shelf-stable nutrition that travels anywhere modern transportation reaches. From the moment fishing nets close around a sardine school to the instant a consumer peels back the can lid, the process spans less than 3 days. What began this morning as 40,000 sardines now sits in a warehouse, as 8,000 sealed cans ready to feed families across 4 continents. The boats have already returned to sea, hunting their next catch. The night shift prepares to begin processing tomorrow's delivery, and somewhere on a dark ocean, sonar screens glow green as captains search for the next silver spool that will keep this remarkable process turning.